All right, let's solve some friction problems here. So we've got this 4.75 kilogram block of wood, and we've got a kinetic coefficient of 0.15 and a dynamic coefficient of 0.45, right? And so what we're going to do is the first question is to just calculate the kinetic force, right? The force of friction is mu times the normal force. In this case, the normal force is the weight of the block. So in all these problems, we just go mu times m times g, right? So that for the kinetic, you're going to use the kinetic coefficient, right? So 0.105 times 4.75 times 9.8, and you're set. So let's just do that. 0.105 times 4.75 times 9.8. That is 4.88775. Yeah? Okay. And that's our dynamic force of friction. And then the kinetic, or our kinetic force, right? And our static force of friction is going to be mu, and this will be the static coefficient, so this guy, right? So that's going to be 0.45 times 4.75 times 9.8. Okay? So 0.45 times 4.75 times 9.8. And I'm getting 20.9475. Okay, so now this is if it's sliding along the surface, that's the force that's going to be opposing us, right? If we want to accelerate it, we've got to actually exert a force bigger than that. This is just the force to see whether it starts to move, right? So somebody exerts 19 newtons to the right. Is it going to move? Well, it's not going to move. It's because the 19 newtons is less than this static force, right? So it's not going to be enough to break it free. Remember, there's those weak little bonds that form, and it just won't be sufficient. So you need to do is say no, because the applied force of 19 newtons is less than the maximum static force of 20.9475. So say what the forces are. Say, label them, the applied force and the static force, right? And then explain whether it will or will not slide. And you're good.